One can use vectors to calculate the area of a parallelogram. If you have a parallelogram like this, then we have that the sides of the parallelogram can be thought of as two vectors. So we have the first vector here, and the second vector, this one. So if you call that B, and call the other one A, then the area of this parallelogram can be shown to be equal to, you take the scalar product of A with, or dot product, with a vector we call B perpendicular. In a moment we'll say what it is. And then you take the absolute value of that. So this formula gives you the area of this parallelogram. And what is B perpendicular? That's just B rotated 90 degrees, either clockwise or anti-clockwise. It doesn't matter. So this is perpendicular to B. So it is same length as B, but 90 degrees from B. We will have more to say about that in the next lecture, but if you have a vector B, how can you find the perpendicular one? So that's a vector with the same length but rotated 90 degrees. Then you just have to switch place on these two and put a minus sign on one of them. So here it doesn't matter if you put the minus here or you put the minus here. If you put the minus on this one, it's clockwise rotation 90 degrees. If you put the minus here, it's anti-clockwise. Alternatively, you can also rotate the first one. It doesn't matter which one of these you rotate. So you can take the perpendicular to the A one also if you like. Then you keep B intact. So this is the same thing. You just rotate A 90 degrees clockwise or anti-clockwise. So have the same length but perpendicular to A. So you do it in the same way as you did here. So you can choose which one of these you like. So let's take an example. Let's say that A is equal to 2, 3 and B equal to 4, 1. Then we can take any of these two. So let's just take the first one. So we need to figure out what B perpendicular is. A is 2, 3. B perpendicular, then we just have to switch place on the components of B. We put 1, 4. And then we put a minus on one of these. It doesn't matter which one. Then we get like this. Then we take the dot product. So that's 2 times 1 minus 3 times 4. So 2 minus 12. And that's just absolute value of minus 10, which is 10. So the area of this one, this parallelogram, is 10 area units. The proof for this formula, we will not go through it here, but it's written in the book for those interested.